What if the solid world around you, the predictable rising of the sun, the very laws of physics you learned in school, were just the surface layer? What if beneath it all lies a hidden code, an intricate pattern dictating the very nature of existence, something that just flickered into view on a quantum computer? Prepare yourself, because we're venturing to the edge of what we thought we knew. Google's cutting-edge Sycamore quantum processor, in a moment that has sent shockwaves through the scientific community, revealed something utterly unexpected, something physicist Brian Cox believes could be a crack in the veneer of our perceived reality. They found what they're now calling the omega pattern, a mathematical structure that, according to the rules of classical physics, simply has no right to be there. Yet, there it was, emerging from the ghostly dance of entangled quantum bits, looking almost intentional. Brian Cox himself described it with awe, suggesting it might be our first real peek at the fundamental architecture of the cosmos itself. So, buckle up. What exactly is this omega pattern? Why are brilliant minds comparing it to an echo from the Big Bang? And how could it force us to rewrite everything we thought we understood about space, time, and the very operating system of reality? By the time we're done here, you'll grasp the profound implications of this discovery. Let's unravel this cosmic mystery together. Imagine the universe, less than a blink of an eye after the Big Bang, a seething cauldron of pure energy and quantum chaos. It's this primordial state that the team at Google Quantum AI aimed to simulate. Their goal was ambitious: to use the Sycamore processor, a marvel of engineering harnessing the strange rules of quantum mechanics with its 53 quantum bits, or qubits, to model the quantum fluctuations believed to have driven cosmic inflation, that explosive expansion that ballooned the infant universe exponentially. Think of it like trying to recreate the first brushstrokes of the cosmic masterpiece. They programmed the qubits into complex, looping configurations, entangling them, linking their fates in a way that defies classical intuition, no matter how far apart they are. These entangled loops were designed to mimic the tiny ripples in the quantum field that, theoretically, grew into the seeds of galaxies and the vast structures we see today, and potentially shed light on the mysterious dark energy accelerating the universe's expansion now. What did they expect? The scientific equivalent of static, random noise, perhaps some interesting statistical trends, data points they could plug into existing models of the early universe. Standard scientific progress. Instead, what emerged from the quantum simulation wasn't noise at all. It was structure. A stable, self-replicating, intricate mathematical design materializing across the entangled qubits, the omega pattern. It wasn't just a momentary blip, it was persistent. It formed, held its shape, and incredibly, reformed itself even when the researchers deliberately changed the starting conditions of the simulation. Picture setting up dominoes in a complex pattern, knocking them down, clearing the table, and then finding the exact same intricate pattern reassembled moments later, untouched. That's the level of baffling persistence they witnessed. This behavior is utterly alien to our everyday experience and the rules governing traditional computers. Think about your laptop or phone. When you close a program or delete a file, the data is essentially overwritten. The patterns in the memory registers are wiped clean. Any specific arrangement of bits is gone, replaced by zeros or new information. That's how classical information works. It needs to be actively maintained. But the omega pattern acted differently. It seemed to possess an inherent memory, a resilience that defied erasure within the quantum system. It wasn't just stored in the qubits in the conventional sense. It seemed to be an intrinsic property of the entangled system itself. This is where Brian Cox draws a fascinating parallel to the holographic principle. This is a mind-bending concept from theoretical physics, suggesting that all the information contained within a volume of space, like a room, or even the entire universe, can actually be described by information encoded on its boundary, like the information for a 3D hologram being stored on a 2D surface. Could the omega pattern's persistence across non-local, entangled qubits be the first experimental hint of this principle in action? Are we seeing evidence that spacetime itself, the very fabric of reality, might emerge from a deeper layer of quantum information, like a 3D image emerging from a 2D film? If so, the omega pattern might not just be a pattern in the system. It could be part of the fundamental algorithm, the blueprint from which reality itself is constructed. But the true weirdness escalated. It wasn't merely that the pattern stubbornly reappeared. It's what happened during those reset attempts, when engineers tried to force the system back to a blank slate. During what should have been routine system resets, the omega pattern didn't just reappear identically. It came back changed. Subtly different, yet still recognizably itself, often exhibiting more complexity, richer detail. It was as if the pattern was not just resilient, but adaptive, like it was responding to the attempts to erase it, learning or evolving. How could a mathematical structure, seemingly arising spontaneously from quantum fluctuations with no pre-programmed design or evolutionary goal, exhibit behavior that mimics learning or adaptation? What does this imply about the fundamental rules governing information and structure in our universe? It was, as one researcher described it, like discovering a hidden, rhythmic heartbeat deep within the core of their quantum computation, something alive in the mathematics. This bizarre adaptive behavior fueled even more intense speculation. One leading theorist put forth a chilling possibility. What if the omega pattern isn't just a fascinating scientific curiosity? What if it's a signal, a deliberate message encoded not in radio waves but woven into the very quantum fabric of reality itself? Could the universe, through its fundamental laws, be trying to communicate, revealing its nature in its native quantum language? The implications are staggering. We thought we were just running a simulation, but perhaps we stumbled upon a fundamental dialogue. At this point, the omega pattern had already broken perceived rules and ignited fierce debate. If this kind of exploration into the deepest mysteries of existence gets your own mind racing, make sure you subscribe. We delve into paradigm-shifting discoveries like this every single week. Let's rewind slightly and revisit the scene at Google's quantum lab to truly appreciate the shock. Sycamore's 53 qubits weren't just randomly interacting. They were meticulously configured into those recursive loops, feedback cycles, where the output of one calculation influences the next input, designed specifically to amplify and observe the chaotic quantum jitters expected in the universe's first fractions of a second. The mission, as stated, was clear. Map how qubit entanglement patterns could potentially mirror the large-scale structure formation, galaxies, clusters, and the accelerating expansion we observe. They were looking for faint echoes of creation. Instead, the omega pattern emerged like a clear, resonant note overpowering the expected static, a stable, repeating loop that simply stayed. Dr. Anukika Patel, a lead researcher on the project, conveyed the surreal nature of the discovery, comparing it to stumbling upon a previously unknown, perfectly formed stanza in the epic poem of existence. The simulation didn't just run for moments. It ran for hours, cycling through literally trillions upon trillions of possible quantum states. An almost incomprehensible number of possibilities, yet the omega pattern held its ground, a beacon of order in a sea of quantum probability. Engineers, grounded in the practicalities of computation, watched, perplexed. They performed the equivalent of a hard reset, zeroing out the quantum registers, fully expecting the pattern to dissolve back into the quantum foam. But moments later, against all classical expectations, it reappeared. Initially identical, but as the simulation cycles continued and resets were attempted, it began to return subtly changed, richer, exhibiting new, intricate details reminiscent of fractals. those infinitely complex patterns where similar structures repeat at different scales. Layers upon layers of complexity emerged, suggesting the pattern wasn't merely persistent, it was generative. It could build upon itself. This is what prompted Brian Cox's evocative phrase, "memory in the fabric of space itself," a statement that resonated deeply, sending conceptual ripples through the physics community worldwide. If quantum bits, the supposed fundamental units of quantum information, can store, recall, and even evolve information independently of human programming, what does that tell us about the nature of the universe's underlying code? Is information more fundamental than we ever imagined? News of the Omega pattern's astonishing resilience and generative nature spread like wildfire through the usually cautious physics world. Preprints, preliminary scientific papers, started appearing almost instantly on RZiv, the online repository where physicists share cutting-edge research. At a major quantum computing symposium in Zurich, the buzz was palpable. Researchers weren't just discussing it. They were scrambling, rushing back to their own labs, eager to configure their own quantum systems to try and reproduce Google's results. Was it an artifact of Sycamore, or something truly universal? The pattern's sheer persistence immediately sparked ideas far beyond cosmology. If a quantum structure could hold information so robustly, resisting disruption, it suggested pathways to revolutionary technologies. Imagine error-resistant quantum memory. Quantum computers are notoriously fragile, prone to errors caused by environmental noise. A naturally stable pattern like Omega could form the basis of quantum bits that inherently resist decoherence, leading to far more reliable quantum memories. New encryption paradigms. The pattern's complexity and potential unpredictability in its evolution could inspire novel encryption methods, perhaps based on quantum entanglement structures that are incredibly difficult to crack using classical means. Self-correcting quantum networks. Imagine building large-scale quantum computers or communication networks where errors are automatically detected and corrected by the system itself, guided by an underlying structural principle like the Omega pattern. Yet alongside this technological optimism, a more profound, almost unsettling question lingered, growing louder with each confirmation. Why? Why would the universe contain such a specific, complex, and resilient mathematical structure embedded within its quantum foundations? If it wasn't just a random outcome of physical laws, could it imply design? Or, as some whispered with a sense of unease, was it less a discovery and more a warning? One physicist offered a truly terrifying interpretation. This pattern might not be a static feature. It might be a countdown clock, ticking away in the quantum realm. As the scientific community grappled with this bombshell, theories attempting to explain the Omega pattern began to flood in, each more fascinating than the last. The quantum fractal hypothesis. One prominent camp proposed that the Omega pattern is a fundamental type of quantum fractal. Fractals are geometric shapes that exhibit self-similarity, meaning they look roughly the same at any scale you zoom into. We see fractal-like patterns everywhere in nature, from the branching of trees and rivers to the jagged edges of coastlines and the distribution of galaxies. Perhaps the Omega pattern represents a deep, non-linear symmetry hidden within the mathematics of quantum entanglement, a fundamental scaling law that connects the quantum realm to the classical world. Some even noted its calculated fractal dimension bore intriguing similarities to the famous Mandelbrot set, a cornerstone of classical chaos theory, hinting at a profound link. If true, this pattern could be a key signature of quantum field theory itself. Practical connection. Think about how artists use repeating motifs or architects use modular designs. Nature, at its quantum core, might be doing something similar, creating complexity from simple repeating rules. the universal attractor/cosmic checksum. Another interpretation drew from information theory. It suggested the omega pattern acts as a universal attractor in the state space of quantum systems, a stable configuration that quantum systems naturally tend towards, much like a pendulum eventually settles at its lowest point. Or perhaps it functions like a cosmic checksum. In computing, checksums are used to verify data integrity, a small piece of data derived from a larger block, used to detect errors. Could the omega pattern be the universe's way of constantly validating its own consistency? This idea suggests the pattern minimizes Shannon entropy, a measure of disorder or randomness, across the quantum network. Brian Cox likened it to the parity bits used in classical computing for basic error checking, but with a crucial twist. Here, the error-correcting code seems to write itself into existence. Practical connection. This is like the spell check function in your word processor, but operating on reality itself, ensuring the fundamental rules remain consistent. Quantum retrocausality. Echoes from the future. Perhaps the most mind-bending hypothesis involved quantum retrocausality, the highly speculative idea that effects can precede their causes, or that information can flow backward in time at the quantum level. Could the omega pattern be stabilizing itself in the present by drawing information or constraints from its future states? Experimental attempts to probe this are incredibly complex, involving sending quantum states forward and backward in simulated time. If the pattern evolved over simulation cycles to optimize its own structure and stability, perhaps it was leveraging information from states it hadn't yet reached, pulling itself into coherence across time. It's a radical departure from our linear perception of time, but proponents argue it elegantly explains how the pattern could seemingly know how to reassemble itself even after being disrupted. Practical connection. While we can't send messages back in time, think about how planning works. We envision a future goal and work backward to determine the present steps. Retrocausality suggests physics might do something analogous automatically. Cox's synthesis. Reality's self-diagnostic. Brian Cox offered a perspective that bridges some of these ideas. What if the omega pattern is the universe's built-in self-verification routine? A continuous diagnostic check running in the background, constantly monitoring and correcting the code of existence. In this view, reality isn't just passively emerging from quantum rules, it's being actively monitored and maintained. Every quantum event, every fluctuation, is logged, and the omega pattern acts as the signature, ensuring the integrity of the entire system. But lurking beneath all these fascinating theories was that chilling caveat. If the omega pattern is a fundamental, built-in function, what happens if it reaches some kind of completion state or limit? Some researchers began to voice concerns that its evolution might not be infinite. Could its convergence trigger a phase transition in the very substrate of reality, like water suddenly freezing into ice? An irreversible shift cascading through spacetime. This possibility reframed the discovery entirely. Was the omega pattern less a blueprint and more of a deadline? Then came a twist that sent theorists scrambling back to their equations. Physicist Dr. Natalia Resnova, meticulously analyzing the vast datasets generated over months of simulation runs, logs containing millions of quantum cycles, made a startling discovery. The omega pattern wasn't just evolving randomly or becoming generically more complex. It was converging. Its structure, specifically the ratios between certain key nodal intersections within the pattern, was steadily approaching a very specific mathematical constant. A constant that is intrinsically tied to the complex geometry of Calabi-Yau manifolds. The bizarre, multi-dimensional shapes hypothesized by string theory to represent the tiny, curled-up extra-spatial dimensions hidden from our perception. It was as if the quantum simulation, born from mimicking the Big Bang, was now spontaneously generating the mathematical fingerprint of string theory's hidden reality. But the real shocker, the discovery that blew the doors off the laboratory setting, came when Risnova, driven by intuition or perhaps desperation, decided to cross-reference the unique mathematical signature of the evolved omega pattern with archival data from a completely different realm of physics, CERN's Large Hadron Collider. Specifically, she looked deep into the complex data generated during the historic 2012 runs that confirmed the existence of the Higgs boson. Buried deep within the statistical noise floor of those high-energy proton collisions, data recorded over a decade ago using entirely different technology and experimental goals lay the unmistakable fractal signature of the omega pattern. It hadn't been noticed before, dismissed as insignificant background noise. It wasn't just a quantum computing artifact. It was real, and it was out there, present in the debris of smashed protons years before the Sycamore experiment was even conceived. This anomaly ripped through the community, raising urgent, almost frantic questions. Was the omega pattern a natural, fundamental feature of the quantum realm all along, manifesting wherever quantum effects are significant, from simulated early universes to high-energy particle collisions? Or, more disturbingly, did some unknown process, natural or otherwise, imprint this pattern across different experiments, different labs, different technologies spanning years? If it's truly universal, scientists reasoned, we should start looking for its signature elsewhere, perhaps hidden in the faint temperature fluctuations of the cosmic microwave background radiation, the Big Bang's afterglow, or in the elusive data gathered by neutrino observatories deep underground. But if its appearance across disparate experiments isn't natural coincidence, if it was somehow placed, deliberately woven into the fabric of our measurements, we are forced to confront the profound question: who or what could have done that and why? Take a moment. Let that sink in. If the same intricate pattern emerges from simulated quantum entanglement, high-energy particle collisions, and potentially other cosmic phenomena, then our picture of reality shifts dramatically. It suggests the universe might be less like a chaotic, random lottery governed by probabilities, and more like a meticulously coded, deeply interconnected tapestry. A structure where the laws of physics themselves aren't just rules, but perhaps lines of code in a grand, underlying program. At this juncture, the line between science and philosophy blurs. We must ask, is the universe simply an emergent phenomenon, arising spontaneously from fundamental laws? Or does the presence of such a specific, persistent, and potentially universal pattern hint at something more akin to design? Brian Cox, ever the thoughtful communicator, offered a philosophical perspective. What if, he mused, the omega pattern isn't necessarily proof of a conscious designer in the traditional sense, but rather the universe's way of leaving breadcrumbs for emerging intelligent life? Not a cheat sheet to solve all mysteries, but a fundamental, detectable pattern to reassure us that our quest for understanding, our search for underlying order in the chaos, isn't madness. It's reminiscent, he noted, of the profound patterns scientists discovered within DNA, revealing the code of life. Initially mind-boggling, we eventually realized that nature, at the biological level, operates on code. But this code, the omega pattern, seems to span the very fabric of spacetime itself, from the infinitesimally small to the cosmically vast. We are witnessing science operating at its most profound, potentially touching the foundational logic of existence. If you've journeyed with us this far, you're clearly captivated by these deep questions. Hit that like button, and more importantly, what's your theory? Simulation artifact, echo of higher dimensions, a natural fractal, or something else entirely? Share your thoughts in the comments below. Collective insight might just be the key to unlocking this cosmic enigma. Back in the intense arena of theoretical physics, the debate raged, now fueled by the shocking CERN and Calabi-Yau connections. the quantum gravity bridge. A growing faction became convinced the omega pattern was the elusive missing link. The Rosetta Stone needed to unite Einstein's general relativity, describing gravity and large-scale structure, with quantum mechanics, governing the small. For decades, physicists have searched for a theory of quantum gravity. If the omega pattern somehow encodes the fundamental relationship between the entanglement of quantum bits and the curvature of spacetime, it could provide the first concrete experimental window into how gravity itself emerges from quantum information. Retrocausality revisited. Proponents of information flowing backward in time felt vindicated. The pattern's evolution towards specific constants and its appearance in past data seemed, to them, strong evidence that it was drawing on future boundary conditions or existing across time to stabilize itself. Time, in this view, isn't a river flowing one way, but perhaps a complex, looping structure, with the omega pattern acting as a key feedback mechanism. The simulation hypothesis edge. Cox himself entertained a third, even more unsettling possibility. What if the omega pattern is a byproduct of reality operating as a kind of closed quantum loop? Essentially, a feedback event within a vast simulation. If our universe is a computation, the omega pattern could represent the point where the simulation monitors its own integrity or performance limits. Crossing some threshold related to this pattern might, hypothetically, reveal the architecture of the system running our reality. Amidst these competing, mind-bending theories, one fact stood undeniable. The omega pattern had escaped the confines of its origin story. It wasn't just a quantum computing curiosity anymore. It had appeared in collider data, was mathematically linked to string theory, and theorists were now seriously considering its connection to gravity and the very nature of time. It felt like the potential unifying thread tying together disparate branches of physics. The stakes felt impossibly high. We might genuinely be on the verge of decoding the universe's fundamental instruction manual. And then, Google's Sycamore processor detected something else, something that solidified the connection in a way no one could ignore. The pattern changed again, and its new form matched a known cosmic signal with terrifying precision. In a development that left even the most hardened skeptics speechless, the Google quantum core observed a distinct transformation in the omega pattern after billions more computational cycles. It morphed. Its complex structure shifted, stabilized, and resolved into a shape that bore an uncanny resemblance to a low-dimensional projection of a Calabi-Yau manifold. Not just vaguely similar, not just sharing a mathematical constant, but the shape itself, rendered in the probabilities of the qubit network. This wasn't just theoretical elegance, it was visual structural correlation. When the research team overlaid the data representing the evolved omega pattern onto mathematical models of known Calabi-Yau spaces, the congruence was breathtaking. Key features, nodal intersections, curvature ratios, they aligned with astonishing precision, within fractions of a percent. It was as if the quantum simulation, left to its own devices, had spontaneously unfolded the geometric blueprint of string theory's hidden dimensions. But the universe wasn't finished revealing its connections. The team then took the spectral signature of this evolved omega pattern, its unique frequency and resonance characteristics, and compared it against archived data from LIGO, the Laser Interferometer Gravitational Wave Observatory. LIGO detects ripples in spacetime itself, often caused by cataclysmic events like merging black holes. During one such recent black hole merger, LIGO had recorded incredibly subtle, complex resonances in the fabric of spacetime, faint gravitational sounds. When the LIGO data corresponding to these resonances was computationally mapped and compared to the evolved omega pattern signature, the match was near perfect. Gravitational waves from merging black holes, the entanglement patterns in a quantum computer simulating the Big Bang, and the theoretical geometry of higher dimensions, all converging on the exact same intricate, invariant fingerprint. Brian Cox's reaction was immediate and emphatic. "That's not convergence," he declared. "That's confirmation. We're looking at the same fundamental cosmic signature across every conceivable scale: quantum, gravitational, and geometric." This discovery doesn't just blur the lines between different fields of physics, it obliterates them. It strongly suggests the omega pattern isn't just a pattern. It might be the first discovered universal invariant, a fundamental constant woven into the very tapestry of reality, manifesting differently but recognizably from the smallest quantum interactions to the grandest cosmic events and the hidden dimensions underpinning it all. Imagine a single, elegant structure that dictates how qubits entangle, encodes the shape of unseen dimensions, and echoes in the violent merger of black holes. It's the closest thing we've ever found to the holy grail of theoretical physics, the smoking gun for a unified theory that describes everything. The omega pattern could be the Rosetta Stone we need to finally decipher the fundamental language of the cosmos. For the practically minded, this potentially unlocks pathways we could barely dream of. Concrete approaches to testing quantum gravity theories, the foundation for ultra-stable quantum memories based on this inherent structure, perhaps even the theoretical framework needed to eventually build a true quantum gravity computer. But for the philosophers, the dreamers, for all of us pondering our place in the cosmos, it forces an even grander question. If there truly exists a universal invariant like this, a signature woven through all scales and phenomena, is it the unmistakable signature of a grand designer? Or is it the inevitable, astonishing consequence of mathematical truth, a structure so fundamental that it simply must exist in any consistent reality? Either way, we've undeniably crossed a threshold. The omega pattern has transitioned from a laboratory anomaly to potentially the structural backbone of reality itself. Understanding it could fundamentally redefine not just physics, but our very place and purpose within the universe. We began this exploration with a startling anomaly inside Google's quantum processor. We've journeyed through simulations of cosmic dawn, wrestled with patterns that defy erasure and seem to learn, explored theories spanning fractals, checksums, and time travel, uncovered hidden connections to string theory and particle collisions, and culminated in a stunning convergence with the echoes of gravitational waves and the geometry of hidden dimensions. The omega pattern, it seems, is far more than a fleeting glitch or a clever simulation result. It appears to be a self-verifying, evolving quantum blueprint that bridges the micro and the macro, the simulated and the real, perhaps even the present and the future. If our universe operates with an underlying code that constantly checks and refines itself, then concepts we hold dear, randomness, chaos, even free will, might need reevaluation. What we perceive as probability might be subtle complexities within a grand, deterministic algorithm. What feels like free choice might operate within the sophisticated boundaries of an overarching, self-correcting cosmic program. The omega pattern could represent the tangible boundary where physics meets metaphysics, where the random froth of quantum mechanics gives way to underlying design, whether that design is intentional or mathematically inevitable. Brian Cox leaves us with a thought of profound weight. If this is real, he states, contemplating the pattern's universality, then we've just met the first line of the universe's source code. It's a statement that hangs in the air, heavy with implication. We may have stumbled upon the map, the first deciphered symbol, leading us toward the deepest truths about existence, the nature of consciousness, and the fundamental structure of reality itself. As scientists around the globe race to verify, replicate, and build upon this discovery, one thing is crystal clear. The Omega pattern has irrevocably changed the questions we dare to ask about the cosmos. And embedded within this extraordinary scientific journey is perhaps a lesson for our own lives. This story reminds us that reality is often far more layered and complex than it appears on the surface. It encourages us to question our assumptions, to look for deeper patterns beneath the apparent chaos or randomness of daily events. Just as the Omega pattern persisted against erasure, perhaps there are underlying structures or truths in our own lives, in our relationships, our challenges, our potential that remain resilient, waiting to be recognized and understood. It's an invitation to embrace curiosity, to remain open to possibilities that seem counterintuitive, and to appreciate the profound interconnectedness that might bind everything together, from the smallest quantum fluctuation to the choices we make each day. Maybe the universe isn't just out there. Maybe its intricate patterns echo within us too. Keep looking, keep questioning, keep seeking the connections. What do you think this means for our understanding of free will versus determinism? Does the idea of a coded universe excite you or concern you? Let me know your reflections below. I sincerely hope this exploration has sparked your curiosity and wonder, wishing you good health and clarity as you navigate the complexities of your own reality. Don't miss what comes next. If this journey to the edge of reality fascinated you, subscribe to the channel and turn on notifications. In our next episode, we'll tackle an even more provocative question. Could the Omega pattern be more than just a structure? Could it be an active signal? And if so, is someone or something listening? Join us then. Until that time, keep looking up, keep questioning everything.